Good evening everyone. Tonight I'm going to tackle about multivariate regression. Multivariate regression is a statistically analyzed data often involves multiple variables rather than just one response variable and one explanatory variable. The number of variables can vary depending on the study being conducted. If mag-use na sila variable, dapat nakadepend po sila sa ilang variable nga gikondak or sa ilang study nga gikondak. To assess the relationship between this multidimensional variables, researchers often to turn the variate regression. Add on, multivariate regression is a method used to measure the degree at which more than one independent or more than one dependent variable are linearly related. The method is broadly used to predict the behavior of the response variable associated to changes in the predictor variables once a desired degree of relation has been established. That's all. Good night.
Multivariate regression is a sophisticated technique used to determine the extent to which various independent variables are nearly related to multiple d- dependent variables. So, kaning multivariate regression is man say method nga gigamit para sa data analysis nga makatabang sa to figure out how several factors nga gitawag siya independent variables nga maka-influence multiple outcomes sa dependent variables. So, the linear relationship is established through the correlational between the variables. So, kaning multivariate regression kay mugana siya by measuring how strongly each variable nga nakakonektat sa lain to another. So, kaning mo na say gitawag og correlational and kanang gigamit siya to build the regression model. By applying multivariate regression to the dataset, researchers can then predict the behavior of the response variable based on a corresponding predictor variables. So, ang mga researchers kay nag-collect sila dataset there is a real world data niya. Ilang gamit ang multivariate regression to kanang understand how the predictor variables like independent factors nga muna ang ang imong mga income or education na maka-influence sa kanang response variables na ang imong imong mga outcomes like spending or imong health. In the realm of machine learning, multivariate regression is commonly utilized as supervised algorithm. So in machine learning kay multivariate regression is a type of supervised learning. So ang meaning na nga if mag-train ka using data where both the inputs ang input ato kay ang independent variables and the outputs kay dependent variables nga man na ila. So it serves as a powerful tool for predicting the behavior of the dependent variables based on multiple independent variables. So meaning na kay multivariate regression is gamit ki siya para makuan bitaw sa mga predictions bitaw. So makatabang na siya understand how different factors the independent variables kanang mag-work together to influence the outcomes sa dependent variables. Example ani, maka-predict ka sa mga sa ka tawo nga sa iyang health based sa iyang diet, iyang mga gipang kaon, exercise o sa iyang tug sad. By breaking it down, we see the multivariate regression is essentially about understand and predicting relationship between multiple factors and outcomes. Thank you.
Good day, everyone. I am Lindy Marie Wanelio once again, and I'm here to discuss the multivariate regression. Recap na lang sa multivariate regression. Multivariate regressions finds the relationship between one independent variable and multiple number of dependent variables. I think Dirk Jarko Zapata will discuss furthermore or give the definition of the multivariate regression. So I have here an example of multivariate regression. I will just attach a picture here for the reference, for the clear reference. So I have x sub 0, y sub 1, y sub 2. We have 0, 1. We have, this is the given value. We have 0, 1, 2, 3, and 4. 1, 4, 3, 8, and 9. And negative 1, negative 1, 2, 3, and the last one is 2. So we have the formula here of the y. So y I is equal to beta 0 I plus beta 1 I x sub 0. So multivariate regression is at least, you must have at least two outcome variables. Two outcome variables that depends on one predictor. So y sub 1 here and y sub 2 here, this is our the dependent variable, and the x sub 0 here is our independent variable. So as you can see, multivariate regressions must at least two outcome variables. So we have y1 sub 1 and y sub 2. So we have a formula here. Y sub 1 is equal to beta 0 1 plus beta 1 1 x 0. Y sub 2 is equal to beta 0 2 plus beta 1 2 is equal x 0. So for this beta here, for the formula, we transfer it to the matrix form. So here we have b is equal, beta is equal to beta 0 1, beta 0 2, beta 1 1, and the last one is we have the beta 1 2. The formula here for the beta is equal to x transpose times x to the power of negative 1 x transpose times y. So first we calculate the inside the parentheses. So we have the x transpose times x. So I have here another table for that. So again, I will just put the picture here for the clear reference. So we have x and y here. So we have x and y here. X, the value of that is 1 1 1, and just copy the given value of the x 0. So y, we have 1 here. So since our formula, we have the y sub 1 and beta 0 1 plus beta 1 1, we just copy it. We have x here, 1, the value of x is 1 1 1, and then we just copy the given value, which is the 0 1 2 3 and 4. For the y, that is the value of y sub 1 and y sub 2. So 1 4 3 8 and 9, negative 1, negative 1 2 3 and 2. So in order, first we have a formula here. First we calculate the inside the parentheses, so x transpose times x. So in order to calculate that, we need to find the x transpose. So how we calculate the x transpose? So it is the basic one. So we have x given here, the rows becomes to columns. Again, the rows becomes to columns. So we have the x transpose here, the 1 1 1 1 and the 0 1 2 3 and 4. In order for us to calculate the x transpose times x, so we have the the value of x transpose, and we have the value of x. So the column here times the column here. So 1 times 1, 1 times 1 is equal to 1, 1 times 1, 1 times 1, and then add up all of that. So we come up with the 5 value. 5, we have the 5 value. So we have here 1, we have column here and then column here. So 1 times 0 is equal to 0. 1 times 1 is equal to 1. And 1 times 2, 2. 1 times 3 is 3. And 1 times 4 is 4. So add up all of that. We have the value of 10. So that's why we have 10. So again, on and on, same process. We have 10 and 30. So we have the value of the x transpose here, 5, 10, 10, and the last one is 30. So next, we have the x transpose x to the inverse, which is the -1. So just calculate it in a scientific calculator. So we come up with a 0.6, -0.2, and -0.25, and 0.1. So the last one, we have this one here. We have beta is equal to x transpose x -1 x transpose times y. So we come up with a value of 1, -1, 2, and 1. So here's our final value of the beta. So 1, -1, 2, and 1. So since our discussion here is how to calculate this beta here, so we have already the value of the betas. So we have y sub 1 is equal to 1 plus 2x0, and y sub 2 is equal to -1 plus 1x sub 0. So the result is 1. We can assume that x right here have already a value of 1. So I think that's the process of how to calculate the multivariate regression. Thank you.
What a Sigma! I am here to discuss time series regression. What is time series regression? Time series regression is a statistical method for predicting a future response based on the response history. It is known as autoregressive dynamics, and the transfer of the dynamics from relevant predictors. So, time series regression can help you understand and predict the behavior of dynamic system from experimental or observation data. The time series regression, it can help you predict the future, the experimental, dynamic, and observation data. Common use of time series regression includes modeling and forecasting of economic, financial, biological, and engineering systems. To give you an example for this, you can start a time series analysis by building a design matrix x plus x and t. Also, a future of regressor metrics, which can include current and past observation of predictors ordered by the time. Then, apply ordinary least squares to multiply linear regression model like this. To get an estimate of a linear relationship of response to design the matrix, the B represents the linear parameter estimate with the computed E, and D represents the innovation terms.
So here is the example of time series regression. I will just put a picture here for you to. So first, the table, we have a table here. So the table below gives quarterly sales figures in RM of a retail giant for the years 2008 to 2010. So I will just put a picture here for a reference. So here we have in 2008, for the quarter 1 we have 20, for the quarter 2 we have 30%, for the quarter 3 we have 39, for the quarter 4 we have 60, and 2009, 40, 51, 62, and 81. The last one is 2010, 50, 64 for the quarter 2, 74 for quarter 3, and 95 for the quarter 4. Next, so we have a question here. Using the ratio to moving average method, calculate seasonally adjusted indices for quarterly. 2. Obtain a regression trend line representing the above data, which is this one. Number 3, the last question, we have obtain a seasonally adjusted trend estimate for the fourth quarter of 2011. So we don't have a 2011 here, so we assume what the quarter 4 for 2011 is. So we have a table here. I will just send a picture. I'll just put a picture here for you for the reference. So we have a table here. So time period, which is the year, quarter, that's the quarter 1, quarter 2, and the quarter 4 and 3. X code, that means the numbers of quarters. So quarter 1 is number 1, quarter 2 is number 2, quarter 3 is 3, quarter 4 is 4, quarter 1 for 2009, that is 5. So continuously, that is the X code. So Y, which is the given data, Y is the 2030, which is the given data. I mean the given value of each year, of the each quarter. Next, we have the 4 QMA, that stands for fourth quarter moving average. So how we calculate this one? So 20, 30, 39, and 60, that is quarter 1 to quarter 4 of 2008. We add this one and divided it by 4, so we come up with a 37.25. Next, how we come up with a 42.25%, that is 30, 39, 60, and 40. So add all up that and then divide it by 4. So continuously, and so on. So we come up with a 70.75 for the 2010 fourth quarter moving average. So, since we have the fourth quarter moving average, we need to calculate the centered average. So, how we calculate the centered average? For this, since we calculate the fourth quarter moving average, we just need to add the 37.25 and the 42.25 in order for us to have the centered average of 2008. We have 39.75. Centered average for the 2008 quarter 4, we have 44.88. So 42.25 plus 47.5 divided by 2, so we come up with a 44.88. And so on. So we last for the 2010 quarter 2, we have 69.0. Next, we have to calculate the percentage of average of all of the centered average. So we have to calculate the centered average. We also have to calculate the percentage of the average. So in order for us to calculate the percentage average, we have to look back the given value, which is of the 2008 quarter 3, we have 39. So in order for us to come up with the 98.11%, 39 divided by 39.75 times 100. So times 100 because we were talking about percentage here. So 39 divided by 39.75 times 100, we calculate the 98.11%. And also the quarter 4 of 2008, 60 divided by 44.88, 133.70%, and so on. So we just finish the calculated table. So here, the percentage of the average of your table, your table, is we just need to copy here, create another table, and copy the percentage of the average. So we have here 2008, 2009, 2010. So we have also here mean, X, adjustment factor, and the seasonal index. So we discuss it later. So copy the old percentage of the average. So we have 2008 quarter 3 98.11, quarter 4 133.70%, 2009 quarter 1 79.40%, quarter 2 we have 91.28%, and quarter 3, and so on and so on. Last for the 2010. How we calculate the mean? We just add the 79.40% and the quarter 1 2010 76.05% in order for to have the mean of the quarter 1 2009 and 2010. So we have 77.73%. We have first we add and then divided by 2. That's how we come up with the mean, and so on. So we calculate all the mean of the quarter 1, quarter 2, and the quarter 3, quarter 4. So we all add up the mean of each quarter. So we come up with a 402.21%. For the X adjustment factor, we just need, it is simple, 400% divided by 402.21%, 400%, because we calculate the 400, so 400% ang atong gigamit. So we come up with a 0.9945%. For the seasonal index, the last one for the hour table, so you just mean times the X adjustment factor. So 77.73% times 0.9945%. So we come up with the 77.30%. 7.73% times 0.9945%. So we come up with the 77.30% and so on. So we come up with a total average of 400%. So we come up with a 400% of average. So we proceed to the number 2 question, which is obtain a regression trend line representing the above data, which is this one and also this one. So for the question 2, we have the formula here, y equals a plus bx. So I just put a reference here for you. So we have a formula here, b is equal to n sum of xy minus sum of x, sum of y, divided by n, which is the total number, sum of x to the power of 2 minus sum of to the power of 2. So we also have the formula of a is equal to sum of y over n minus b sum of x minus over n, or we come up with a formula which is the given. This is more so, or other formula of a is equal to y minus bx. So we create another table for the question number 2. We have x code, y, xy, and x to the power of 2. So for the x code, I mentioned earlier, for the 1, 2, 3, 4, 5 of how many each year and each quarter of the number. So we have the total of x code 12. So add all of this, we come up with the 78. Also for the y, that is the given value, which is 20, 30, 39, 60, and so on. So total average of 666. For the xy, x code times y. So 1 times 20 is equal to 20. 2 times 30 is equal to 60. 30 times 39 is equal to 117, and so on. So also, after you add the xy, we have to come up with the average of 5,669. So we already calculate the x code, the y, the xy, and the x to the power of 2. So calculate for the mean, we have 78 divided by 12. We have 6.5. And for the y, we have 6 with a total average of 666 divided by 12. 12 because that's the x code we have, 1 to 12, so we use it. The divided by 12 is equal to 55.5. Now we calculate the formula of b. So we have here n is equal, that is the number of value, total number of value, So xy, we have 569. We come up earlier for that. X is 6.5. That is for the mean. And y, we have 55.5. X to the power of 2, that is 650. So for the formula of b, we have sum of xy minus sum of x, sum of y over and sum of x squared minus sum of x to the power of 2. In order for us to calculate the b, just follow the formula. So 12 times 5, or close upper parenthesis, 5,069 minus 78. 78, that is for the x, total number of x code. And for the y, we have 666. That is the total number of total value of y. Over 12, 650 minus 78 to the power of 2. So we come up with a 6,828 minus 51,948 over 7,800 minus 684. So the total of value of b, that is 5.17. Now for the value of a, we have the formula of a is equal to y minus bx. So mean y, so we have 5 point. So for the a, we have the formula of mean y minus b min x. So 55.5, that is for the mean value of y, minus 5.17, which is the value of our b earlier, and the 6.5, that is the mean of x code. So add all of this, we come up with a 21.9. That is the value of a, 21.9. Next, that is the answer for the question 2. So for the question 3, obtain seasonally adjusted trend estimate for the fourth quarter of 2011. So we just assume the value of fourth quarter of 2011, since we don't have the 2011 in it, and that's the time series regression. So next, for the value of y, for the formula, y is equal to a plus bx. So 21.9, that is the value of a, plus 5.17, that is the value of b, and y is equal to 21.9 plus 5.17 times 16. Why 16? Because we estimate for the fourth quarter of 2011. So last counting is 12. So first quarter of 2011, that is 13, 14, 15, and 16. That is the fourth quarter of 2011. That's why we use 16 here. So y is equal to 104.62. So, or the question of 3 is obtain a seasonally adjusted trend estimate for the fourth quarter of 2011. So we conduct the estimate for the fourth quarter of 2011. So 104.62 times 130.80 over 100. Why 130.80? That's because that's the total of seasonal index for the fourth quarter. That is 130.80%. So we use 130.80% because we estimate the fourth quarter of 2011. So we use the last fourth quarter that we came up earlier. So 104.62 times 130.80 over 100. So the total of 136.84926%. That is the expected sales for the fourth quarter of 2011. So that's how you come up with the time series regression analysis.